All right, welcome back. We're going to do part 2 now of section 7.3, which is on finding reference angles. So the rest of this is about using those. So let's look at that definition and then we'll do some examples. So the definition of a reference angle says, let theta be an angle in standard position. Okay, so again, on the origin, the reference angle for theta is an acute angle, theta prime, formed by the terminal side of the angle theta and the horizontal axis. Remember, I keep pushing this, but everything you do in trig, you draw to the horizontal axis, the x-axis. You never draw anything to the y-axis, okay? So same thing goes with reference angles. You're going to go from the terminal side to the horizontal axis, okay? All right, so we're going to find some reference angles, and here they're kind of showing you how to get them. But a lot of this is just kind of common sense. So this picture is showing you that if you have an angle in the first quadrant, okay, this is first quadrant stuff, first quadrant, okay, then the angle that you make with the x-axis is the same thing as the reference angle. So theta and theta prime would be the same thing, okay, because that's the distance it is from the x-axis. So that would be the angle measure. If you're in the second quadrant, okay, so if your terminal side is in the second quadrant, here's theta, okay, there's the angle, let's say that's like 120 degrees, then this would be the reference angle, theta prime. It's from the terminal side to the x-axis. The way that you find that is to take 180 minus the angle, okay? If you're doing a radian, then it would be pi minus the angle, same thing, 180 and pi are the same. Okay, so again, if this was 120, then this would have to be 60. So the reference angle would be 60 because 120 plus 60 gives me 180. So I'm trying to get to the x-axis. If you're in the third quadrant, okay, so if you have an angle whose terminal side is here, then the angle itself would be the whole angle. So let's say that was, I don't know, 250 degrees, whatever it is, 250 degrees, okay? Then theta prime, the reference angle, would go from the terminal side just to the x-axis, okay? So because these angles have to be acute, you wouldn't go all the way to this x-axis. So I usually always tell you guys, remember, it's just to the closest side of the x-axis. So it could be over here, it could be over here. You just go to the closest x-axis you can because the angle you give has to be acute. So it's got to be less than 90. No reference angle is bigger than 90 degrees. Okay, so think about that. If it's 250, what would this be? Well, then I would take 250 minus 180, right? 250 minus 180 would give me the difference right there. Okay, so that's how you would find that. And again, you could use pi if you're in radians instead of 180. When you're in the fourth quadrant, now we're going back to the right side. So if you have an angle whose terminal side is way over here, so let's say that's 300 degrees, way over here, then your reference angle is going to be from the terminal side to that closest x-axis right here. So 300 degrees and what would give me 360, so that would also have to be 60. So there's the formula. You would take 360 minus theta. So a lot of you don't need to memorize this formula because you can kind of see it and most of you can figure it out. But if you need the formulas, then this is what they are. Okay, so you have to remember which one goes in which quadrant. It's by quadrant, where the terminal side is. All right, so let's find some reference angles. The first one is 225 degrees. 225 degrees, remember, is in the third quadrant. Okay. Now here's where it's important. If you know that 225 degrees is one of those special angles, it's 45 degrees away from the x-axis, then I automatically know that that's 45 degrees. Okay, so that's one way to do it. Now if you forget that that's 225, when you're in the third quadrant, the way that you find the reference angle is to take the angle and subtract 180 from it. So that would give you the 45 degrees. Okay? But again, if you know the degrees, and if it's on the unit circle, then that kind of makes it a little bit easier. All right, 11 pi over 6. Remember, that's your pi over 6 numbers. Those are the ones closest to the x-axis. And 11 pi over 6 would be way over here, right? There's 11 pi over 6. This was 225. Didn't write that. That was 225. Okay, put my arrow here so that I know that I went all the way around. So remember, that's 330 degrees. So your reference angle is right here. So that's 30 degrees, and 30 degrees in radians is pi over 6. If you forget, want to use the formula in the fourth quadrant, the formula would be 2 pi minus the angle, which is 11 pi over 6. 2 pi, get your common denominator. 12 pi over 6 minus 11 pi over 6 is 1 pi over 6. Okay, so that's how you find them in the fourth quadrant. So I'm finding them without needing this because I can see it. So if you can visualize it and you know your angles, that helps a lot. But the formula, it always works, so that's fine if you have to use that. All right, negative 2 pi over 3. So remember 2 pi over 3, when you count your pi over 3, those are the ones that are close to the y-axis. So 2 pi over 3 would be 1 pi, 2 pi over 3 here. But we're doing negative, so this would be negative pi over 3. So this would be negative 2 pi over 3, right this way. All right, so again, my reference angle is here. Okay, this would be theta prime. I know these are 60-degree angles. Okay, so I know that that's 60 degrees away from the x-axis, so that has to be pi over 3. Again, when you're negative, you got to be careful, okay? So when you have a negative angle, you need to kind of think about where it is up here. It's kind of a little tricky when you're doing reference angles because those formulas only work for positive angles. So you kind of would have to do the opposite, okay? So if I'm looking for this reference angle, if you think about it, in your third quadrant, you're supposed to take this angle minus pi. Well, that's not going to give you the right answer. So when you're doing negative angles, you would actually add pi, okay? So it's a little bit backwards, a little confusing. So you just have to kind of think about where you are on the circle, and that would help you because I know that this 60-degree angle, I know that I'm 60 degrees away, so that kind of helps. So always do the opposite when you have a negative angle. So instead of subtracting, you're going to be adding. So this would be negative 2 pi over 3 plus 3 pi over 3, and that gives you the pi over 3, okay? All right, 390 degrees. I got to go once around the circle, that's 360, and then 30 more, right? So that is 390 degrees. So here's your reference angle. And we just said if we went 360, then that has to be 30, right? So you can do a lot of these without the formula. Now you're in the first quadrant again, and that's supposed to be your angle, right? There's no formula in the first quadrant. So when you go bigger than 360, what you have to do is subtract 360, get the angle that would get you back to the first quadrant, okay? Or back into where you can do your formulas, okay? All right, there is no reference angle for quadrantal angles, so those don't exist because there's no number acute angle for those, okay? And now we're going to talk about evaluating trig functions and using reference angles. So it says to find the value of a trig function of a given angle, determine the function value of the reference angle, and then affix the appropriate sign based on the quadrant. So that all goes back to what we did in the first part, where we know the corresponding angles. Remember, all the orange ones had the same values, the signs were just different. So that's what they're saying to do here. Figure out what the function value is with the reference angle in the first quadrant, and then based on where it is, we'll figure out the sign. Okay? All right, so we got 6 of these to do on this page. So what is the cosine of 135? Okay. So where is 135, and what is its reference angle? So 135 is over here, right? This is 135. It has a reference angle of 45 degrees, right? So what it's telling you to do is just look at, I'm going to write these points here. So here's pi over 6, and again, this is good practice. You should know these. So there's my values. Now I know that's 30, 45, and 60, so I'm not going to write the angles, but that's 30 degrees, 45, and 60 degrees. But I'm going to write the ordered pairs. Okay. Again, I know these, and you guys need to learn these. You need to be as fast as I am at writing them down and figuring them out. That will give you a big head start to trig. All right, so 135 is the same reference angle as pi over 4, 45 degrees. So I know these coordinates are going to be square root of 2 over 2, square root of 2 over 2, except for the signs. So in the second quadrant, I go left. So cosine will be negative. So I know that, I don't know why it says theta prime. Oh, theta prime is the reference angle. Okay, I forgot what that was there. All right, so I know the reference angle is 45 degrees. So again, we're going to use this point. Okay, we're doing the cosine, which is the x value, and I know that I'm in the second quadrant, so it will be negative. So that would be my cosine value for 135. And again, if you have your unit circle, we already did that, and we know that 135 has a cosine of that and a sine of that, right? We did that earlier, but you need to try to do this again, hopefully in a few days where you don't have to look at that unit circle. All right, the sine of 240. Okay, where is 240 degrees? That is down here. All right, so 240 degrees, this is 30, so this would be 60. So the reference angle is 60 degrees. So on the unit circle in the first quadrant, your 60 degrees ordered pair was 1/2 square root of 3 over 2. We're doing the sine of this number, which will be that value, but because we're in the third quadrant, the sign is negative. So that would be our value. Okay. All right. 5 pi over 6. Okay. We know that that's over here. A little trick I told you, right? 5 pi over 6 and 7 pi over 6 are the guys closest to pi, right? So that reference angle, now if we're doing radians, we need to answer in radians. So I know that this is pi over 6, 30 degrees away from the x-axis. I know my pi over 6 numbers automatically. So I'm looking for the tangent, which is y over x. So that's going to be 1 over the square root of 3, okay, y over x. So when we divide, we get 1/2 times 2 over the square root of 3. So we end up with 1 over the square root of 3, which remember we have to rationalize square root of 3 over 3. Okay. Now I'm going to give you a little trick on tangents. Anytime you divide on the unit circle, all your denominators are 2. Right? Notice everything on the unit circle, every ordered pair has a denominator of 2. Okay. So when you start dividing, you don't really have to go through this, because if you're always dividing with a denominator of 2, when you flip and multiply, those 2's are always going to cancel out. So notice what you're left with. You're left with the numerator over the numerator of y divided by x. That's going to happen all the time, and you can do it a few times until you believe it, but that will always happen. So I knew automatically that the tangent was 1 over the square root of 3. I didn't have to go through this, but I wanted to show you so you would know that. All right, negative 11 pi over 6. Negative 11 pi over 6. And I don't know why that's there, but that should not be there. Okay, so I know 11 pi over 6 is 330 degrees, so negative would be this way. And then this would be 30 degrees right here. But I got to write it in radians, so that would be pi over 6. Now, just because the angle is negative, remember reference angles are always positive. There are acute angles between 0 and 90, so it's just whatever that distance is. All right, so again, we're using the square root of 3 over 2 and 1/2. That's our point at 30 degrees. We want the cosecant, which is the reciprocal of sine. We're in the first quadrant, so it's going to be positive. So that would be 2 over 1. Okay. So again, just because this is a negative angle doesn't mean this is angle. It matters where you are. What quadrant is the terminal side in? All right, 540. Okay, 540 is 300, and that goes around more than once, right? So 540 minus 360, that's 180 degrees. So positive, so we're going to go around once and then to here. Okay, so that's 540 degrees. There is no reference angle. Okay, remember there are no reference angles for quadrantal angles, but we can do the cotangent. That point right there is -1, 0. Cotangent is x over y. So we're going to do -1 over 0, and that is undefined. Okay? All right. Last one, 5 pi over 3. Remember the pi over 3s, you count 1, 2, 3, right? So 1 pi over 3, 2 pi over 3. This was 3 pi over 3, 4 pi over 3, 5 pi over 3. So that would be down here. Okay, so I know this is 60 degrees. So that's pi over 3, reference angle, right there. Okay, and so my pi over 3 numbers are 1/2 square root of 3 over 2. In the fourth quadrant, secant is the reciprocal of cosine. So cosine is positive here. So again, that would just be 2 over 1. Okay. All right. Last few examples. So here we're looking at answering these questions. That just depends on what they give you. So these are all good problems that you could be asked. So look at example 8. Find two angles between 0 and 360 where the cosine is equal to negative square root of 3 over 2. Okay, so where would the cosine be negative? Cosine is the x value, so that would be in this quadrant and this quadrant. Okay, if I go this way, cosine would be positive. Now, what angle has a cosine of the square root of 3 over 2? Remember, that's over here at 30 degrees, right? That's square root of 3 over 2, 1/2. So I need this angle and this angle. Those are the two that would have that same value. So I'm in degrees, problem is degrees, so this angle would be 150. And this angle would be 180 plus 30, so that's 210, right? Okay, so notice how I did that. I got to figure out cosine, so I know that's the 30-degree angles. And I knew which side it was on because these two have a positive x value. These two had the negative. And then I just have to figure out those reference angles, know which angles those were. All right, example 9. Given that the sine of theta is negative square root of 55 over 8 and the cosine is less than 0, find the cotangent and cosine. All right, so this is obviously not a number on the unit circle, right? This is going to give us a different value. So we just have to figure it out. So if the sine is negative and the cosine is negative, that's what this says, right? This means less than 0 means negative. So in what quadrant is everything negative? That would be down here. So I'm going to draw an angle in the third quadrant, and it's theta, always at the origin, and we always go to the x-axis. So the sine is the square root of 55 over 8. So sine is opposite over hypotenuse. So this would be the square root of 55, negative, and this would be 8. Okay, so not the unit circle because the radius is 8. Okay, but I'm still using the same information because I know that I can find these values. So I need to figure out this value by doing the Pythagorean theorem. Okay, so remember this is your hypotenuse. So 8 squared equals negative square root of 55 squared plus x squared. That's the one we're missing. Okay, we're missing the x value. We have the y. So 8 squared is 64. The square root of 55 squared would be 55. And when you square it, a negative times a negative is positive. Subtract 55 from 64, we get 9. Take the square root, we get 3. So this side is 3. So now I can find any other value, any other trig function, okay? So the cotangent is x over y, okay? So x over y, so 3 over negative square root of 55. We'll simplify that in a minute. And then the cosine, okay, did that wrong. That is not true. We're not on the unit circle. Sorry. Let's do that again. Cotangent. Cotangent, if we're not on the unit circle, we have to do adjacent over opposite. Okay, just want to make sure we're doing this the right way. Sorry about that. All right, so cotangent is the reciprocal of tangent, which tangent is opposite over adjacent, so this is adjacent over opposite. I'm really sorry about that. I don't want to confuse you guys. All right, so we need to do the adjacent side, which is negative square root of 55. Adjacent side, which is 3. And the opposite side of theta is negative square root of 55. All right, so we're going to do 3 over negative square root of 55. And I know it came out the same, but not all of them will, so you got to be careful with these, okay? Now we can rationalize that, multiply the top and the bottom by the square root of 55. So we're going to end up with negative 3 square root of 55 over 55. Remember, you have to rationalize these. Don't leave radicals in the bottom. All right, then the cosine of theta would be the adjacent side over the hypotenuse. Okay, so cosine would be adjacent, so that's 3 over the hypotenuse with 8. And since I'm going left, it's negative. Remember, we're in the third quadrant. So negative 3 over 8. Okay, so yeah, we went left 3, so don't forget. I don't usually put the signs on a triangle because, I mean, I kind of go by what quadrant I'm in, but if it helps you, if you go left and put the negative there as well, okay, that way you won't lose your signs. But because I was in the third quadrant, then I know all my cosine sine values are going to be negative, okay? And now I just said that, and so, yeah, this is, I do this stuff too sometimes, so all students take calculus. Remember, down here, the tangent is positive. So I just looking at my answers and knowing that I did something wrong, because if tangent is positive, so is cotangent. And so that's what happened here. I didn't use the negative 3. So the adjacent side was negative 3. So I would end up with a positive answer here. So, you know, it's easy to mess up on signs. So that's why this, I guess, a good problem for you to see me do is that I checked it. I looked at what quadrant I was in and I knew something was wrong. Okay, so it's very easy to kind of lose that sign. So again, I'm not one to usually put those because that messes me up. I usually look after the fact and say, all right, I'm in this quadrant, what does the sign have to be? Whatever makes more sense to you is fine. Okay, but just double check. Okay, double check and make sure. So I know that only the tangent and cotangent are positive here. Everything else has to be negative. Okay, so good example of your teacher messing up, but she caught herself. So now, if you'll notice why I changed to these with the trig functions, because otherwise the cosine would have just been x, and that's not right. Negative 3 is not the cosine of this angle. Okay, and again, I can only do x and y when I'm on the unit circle. So because this radius was 8, I had to go back to my regular trig functions, okay? So that problem is good to be right here because we know we've been doing unit circle this whole section, so that's good. All right, so here's another one. The secant of theta is 41 over 40, okay? And theta is in quadrant 4. So use the fundamental identities to find the tangent and the sine. Okay, so we're in quadrant 4, so I'm going to draw, doesn't matter, but I'm going to draw an angle in quadrant 4, which means it's going to go to the x-axis. Here's theta, there's the right angle, right? All right, so secant, remember, is the reciprocal of cosine. Cosine is adjacent over hypotenuse, so this will be hypotenuse over adjacent. Okay, so the hypotenuse will be 41, and the adjacent side will be 40. So this will be 41 and this will be 40, okay? Now, so I look at this problem already, I know I'm in the fourth quadrant, so I know my signs are going to be positive, negative, right? I'm going to go right down. So this is 40. When I put this number in here, when I find the Pythagorean theorem, I just put it in as a positive number. And that might mess with some of you because you're like, well, you went down, why is it negative? Again, like I said on the last problem, if that helps you to put the plus and minus there, that's fine. But when I learned this, you know, this is a triangle. Triangles have positive lengths. So it's just how you see it. So I don't want to confuse you on that. I'll put the negative there, but again, I'm just doing it by looking at what quadrant I'm in. So I know what my signs are going to be, okay? All right, so we're going to do the Pythagorean theorem. So I have x squared plus y squared is what I'm looking for, equals that squared. All right, so x squared plus y squared equals r squared, our radius, right? So we have 40 squared plus y squared equals 41 squared. So 40 squared is 1600. 41 squared is 1681. Subtract 1600, we get 81. Take the square root, we get 9. Okay, so that is negative 9 if you want to look at it that way. Not a decimal, it's just a smudge. All right, so now I've got my side, so now I can do what they've asked me to do. So the tangent is opposite over adjacent. Okay, now again, I'm in the fourth quadrant, so the only thing positive down here is cosine and secant. Everything else is negative. So I know this is negative. So if I'm looking at theta, the opposite is negative 9, the adjacent is 40. But always check your signs because you could mess up and not put in a negative number there, okay? Okay, the sine of theta, sine is opposite over hypotenuse. Okay, so theta, the opposite, negative 9 over the hypotenuse, negative 9 over 41. Okay? All right, so again, in trig, you got to be real careful with the signs. If you put positive answers there, you're going to get it wrong, and I can't give you credit for just missing the sign. That is totally wrong. So you have to be very careful when you answer these, okay? All right, so you got a lot to do in this section, okay? A lot of studying, a lot of memorizing. Please do that, okay? Those of you that are going to struggle are not going to learn this stuff, and that's why. If you're already confused, then send me an email and we will go over stuff. You have got to know this, okay? This is the foundation for what we're doing for the next few months. So please make sure that you're getting this stuff down, okay? Don't just sit back and say, I don't understand. You need to understand this. I want you guys to do well, pass the course, so it's important that you know this, okay? All right, so get to work. Let me know if you have any questions, and I'll see you back here next time.